Hi folks, Howard here. Welcome to Complexity Unraveled. This is the third part of a four-part series on the global state through the lens of US-China competition. In the third part, New Industrial Revolution, we will have a look at a much discussed topic, Industry 4.0. Although, instead of having a technology-centered discussion, we will place our emphasis on the implication of Industry 4.0. Especially how it might change some of our fundamental theses on the trajectory of future global economy. If you haven't checked the primer yet, please consider to do so. It will give you a general idea of the topics we cover in this mini-series. Have you ever wondered why people always talk about China so much, especially in the business world? I mean, there are many reasons. For instance, China has a gigantic domestic market, and even surpassed the US in terms of purchasing power parity as early as 2017. It has been the world factory for more than 2 decades, and made in China has become a crucial part of global economy. From massive machinery to simple household appliance, Chinese products are literally everywhere. There's no doubt that the meteoric rise of Chinese economy and the technology sector have turned China into a force to be reckoned with. But there is also a quite simple explanation. In the past 10 years, China has been the undisputed growth engine for the global economy. Right before the pandemic, China's growth accounted for almost 40% of the global growth. If the Chinese economy stagnated, we would have to slash the global growth target almost by half. With all that being said, no country with a $15 trillion economy could keep growing at over 10% year over year forever. China has slowed down considerably, and inevitably the global economy has slowed down. I cannot exactly remember since when we started discussing the question who will replace China and become the next growth engine for global economy. But one thing for sure, in almost every strategic planning cycle I was part of, this question was right there sitting on the agenda. More often than not, India and Southeast Asia were presented as the answer to this trillion-dollar question. Despite of being in their early stage of economic development and low GDP per capita, both economies are ranked among the top 10 largest economies in terms of nominal GDP. And there's still more to come. The rationale behind it was quite simple, almost like a carbon copy of the Chinese success story. You know, things like large population, cheap labor, young demographics, relatively low degree of modernization, business-friendly policy, and so on and so forth. The question is, how sound is this comparison? To answer that question, we have to revisit the rise of China as an economic powerhouse. It would probably turn this video into an hour-long documentary if we want to have a full-blown in-depth analysis. So instead of that, let's briefly look at the critical factors behind China's economic reform. Even though the economic reform officially started in 1978, the first few years was rather uneventful. For those who are not familiar with the topic, the Cultural Revolution ended in 1976. After 10 years of social, political, and economic turmoil, China was a wreck. It took China a while to re-establish the social order and political stability. The economic reform truly took off in the third stage, starting in the early 90s. China's population had already exceeded 1 billion at the time. The size of the labor force was as strong as 650 million with an extremely competitive wage level. In the early 90s, not only Western companies were looking for cheap labor, even in Asia, manufacturing became simply too costly in countries like Japan, South Korea, Hong Kong, and Taiwan. And they found that alternative in China. With massive foreign direct investment, foreign companies started building their manufacturing sites in China. It created jobs, led to higher employment and higher salary. Higher disposable income encouraged higher spending and resulted in higher economic activities. The growing economy, in turn, stimulated higher education of the younger generation, who then formed a better qualified workforce. The higher skill ceiling once again allowed more sophisticated and complex products being manufactured in China. With more and more companies moving to China, the fragmented manufacturing and assembly sites expanded into an integrated supply base. Even though it's a rather oversimplified illustration, it should be quite obvious it was a self-reinforcing cycle. For many who argue that the manufacturing will be moved out of China and relocated to India or Southeast Asia, the general idea is that the same economic cycle will repeat itself in those regions, and therefore a similar explosive growth would be a likely outcome. But there are several issues we should be aware of. First of all, industrial automation was largely non-existent at the time in China. Labor cost was the key. Back then, the salary gap between Western developed countries and China was more than significant. Let's take the 1990s salary as an example. An American full-time employee's annual salary was roughly $24,000. In China, in the case of an average employee, the annual salary was only $450. People earned less than $35 in a month. The difference in salary was a whopping 50-fold. Comparing the current salary level in China with India or any Southeast Asian nation, the gap is much smaller. Even compared with India, the country with the lowest average salary, the difference is merely 6-fold. Secondly, the products outsourced to China at the beginning of the economic reform were simple products without any technical sophistication, and required rather low skill level. These were low-end, low-cost, low-tech products such as toys and textile. It helped China to slowly get over the learning curve. The products today, though, are way more sophisticated than 30 years ago, which require not only a higher skill ceiling, but also an extended supply chain. There was a foreign company exodus during the height of the recent US-China trade war. Many companies realized afterwards moving out of China doesn't substantially improve the supply chain resilience. I mean, even if you can produce elsewhere, you still more than likely have to rely on the Chinese suppliers. From raw materials to components, from assembly to logistics, the massive supply base and the integrated infrastructure in China were gradually built over a period of 30 years. You can easily move a manufacturing site out of China, but the entire ecosystem for the manufacturing sector is a totally different story. Last but not least, let's talk about an extremely important aspect which people often ignore. The Chinese success story is not a miracle. China was given the time and the room to grow into what it is today. And China had help, even from the United States. The US-China relationship has always been a rather bumpy one. From the Korean War in the 1950s to Nixon's visit to China in 1972. From Belgrade embassy bombing in 1999 to the spy plane standoff in 2001. Into the new millennium, the tensions started rising in the Taiwan Strait and South China Sea. Ever since Trump administration, the US-China relationship has been lowered to a freezing point. With all that being said, despite the ups and downs in the past, it's a fact on the ground that under the policy of engagement during the Cold War era, US helped China to grow its economy. US wanted a prosperous China and worked hard to integrate China into the global economy and international institutions like WTO. US did all this based on the assumption that China's political system would change over time. Of course, it didn't happen. It doesn't really matter whether we call the policy of engagement a miscalculation or a simple blunder. Fact is, without the help from US and its allies, China wouldn't become an economic superpower as we know today. Considering all the factors, we have to admit that the circumstances under which China jump-started the economy was nothing less than a perfect storm. It is rather questionable whether this kind of perfectly aligned conditions could be duplicated once again. Just for a second, if you think about what China has achieved, it's actually quite impressive. They became the second largest economy back in 2010, dragged 1.4 billion people out of poverty in merely 4 decades, sent people into the space, achieved quantum supremacy, leads the 5G deployment, has the most cutting-edge AI and all these amazing technologies. You probably also have the impression that China is indeed a powerhouse. But do you guys remember a controversial movie called Borat, where they made fun of Kazakhstan? The Kazakhstani government almost sued the production company because of the way how Kazakhstan is portrayed in the movie. Well, here's the thing. In reality, Kazakhstan is actually doing better than China. Even in Asia, on the GDP per capita basis, China only ranked 15th. Not globally, only the 15th place in Asia. There are definitely two ways to interpret this. Some people would argue China's economic success is just a facade, like Japan's economic bubble in the 80s and 90s. Sooner or later, it will collapse like a house of cards. Just look at the real estate sector, aging demographics, and extreme wealth gap in China. I mean, these are some legitimate arguments. China has lots of problems, probably more than people like to admit. But we would suggest at least considering the other side of the story. Especially if you believe that we are entering an age of transformative technology. Looking at this chart, one could also argue, this is incredible. None of the tech superpowers has this much room to grow their economy. And none of the less developed economies has such an impressive technology advantage. China certainly has the room to further grow their economy. Even if the GDP per capita doubled, it would merely put China on the same level as Bahrain, but with a $30 trillion economy. A recent economic forecast estimates China's GDP in 2050 to reach an eye-popping $60 trillion mark. Whether the Chinese economy could continue its phenomenal run, double or even quadruple in the next few decades, technology would be the key. Many people are convinced that transformative technologies will bring profound changes into our society and fundamentally alter our way of life. But I think it's also fair to say, to date, no one could precisely quantify the so-called transformation and put some real numbers on it. Even though the concept of Industry 4.0 has been around for more than a decade now, we still haven't figured this one out yet. We know what lies beyond this piece of puzzle. It would be a time when software is writing software and machines are building machines. I mean, even though nobody has solved the entire puzzle yet, companies are making targeted effort to address small fragments of the puzzle. In almost every tech sector, we are seeing the prelude to something of great potential. NVIDIA introduced the Omniverse platform to create a foundation for the industrial metaverse. Unreal Engine 5 set a new benchmark for physical simulation and revolutionized the way how graphic rendering is done. DeepMind is known for developing cutting-edge narrow AI like AlphaGo and AlphaFold. At the same time, it's also exploring the potential of general-purpose AI. And let's not forget Tesla. Pivoting into the whole machine-building machine concept, it goes to such lengths to give the Tesla bot the highest priority in the company. We are quite optimistic about the future of Industry 4.0. After all, the smartest and brightest from our generation are working on it. And we are seeing some very promising results, an early taste of what might come. Let's look at one example together. Google's use of AI in their TPU design. The floor planning to be specific. Since the findings were published in the leading scientific journal Nature, this achievement was widely covered by the media. But before talking about what AI actually achieved in this case, let's briefly cover the basics of floor planning. The modern chip design has come a long way. Intel 8086 had only 29,000 transistors. 40 years later, Apple's M1 has 16 billion transistors. Quite a jaw-dropping number. Although they're more than just transistors on a chip. Generally speaking, a computer chip has dozens of blocks which are connected by tens of kilometers of wires. As for the blocks, for example, memory components are grouped together as a macro. By putting logic gates together, you get a standard cell. Chip floor planning as part of the hardware design is essentially an optimization problem. It involves placing all these blocks onto the chip canvas in consideration of defined performance metrics, like power consumption, congestion, wire length, density, timing, and so on and so forth. Sound quite simple, doesn't it? Just like putting chess pieces on the board without violating the rules. I mean, conceptually speaking, it's indeed comparable with a board game like chess or the game of Go. But size does matter. In the case of chess, the number of possible configurations is 10 to the power of 123. For a long time, the game of Go was considered as the holy grail, because the number of possible configurations reaches 10 to the power of 360. That is a staggering number which often gets compared with the total number of atoms in the known universe. In the case of floor planning, the number of possible states reaches as high as 10 to the power of 9,000. I fail to find anything to draw a meaningful comparison with that number. So I'm gonna just leave it at that. 10 to the power of 9,000. Probably only few people can wrap their mind around this number. Google used the 10,000 curated floor plans to train their AI, and achieved some pretty amazing results. It took AI 24 hours to create a chip design that is, qualitatively speaking, on par with the benchmark. As for the benchmark design, it took human experts at Google who were assisted by state-of-the-art EDA tools roughly 6 to 8 weeks to complete. That is well over 1,000 man-hours. In terms of efficiency gain, we are looking at a whopping 98% time reduction. There is also massive cost-saving potential. Advanced chip design using 16 nanometer processes costs in average over $100 million. Shifting to 10 nanometers pushed the cost to $170 million. And the move to 7 nanometers costs roughly $300 million. With 5 nanometer chips, the cost would be on the order of $500 million. Nearly half of that cost has been for software. The application of AI could significantly drive down the development cost. We should point out, floor planning is only part of the chip design, and Google's experiment only involved 4 different types of blocks. AI is not yet able to design a chip from scratch. Nevertheless, it perfectly showcases the potential of transformative technology. One day, if all these amazing technologies could work together as a cohesive piece, serve as an enabling platform, what could be built upon that foundation will only be limited by our imagination and creativity. If that is the case, who will replace China is likely to remain an open-ended question, and the global economy might well be accelerating once again. I hope the third part of this series could be of some help to you. If you are interested in this topic, we have 3 additional videos to shed some more light from geopolitical, macroeconomic, and governance perspective. If you want us to have a deeper look into any of the topics mentioned in the video, feel free to drop a comment. Thank you for tuning in, and take care.